Let's talk about the truth table. Today I would like to discuss with you this truth table and how can we construct it. We can see that we have different logical connectors in the table as the conjunction. So we have A and B, we have the negation of A, we have the disjunction, so that is A or B. Also we have the implication, so if A then B, and we also have if and only if. Yes, so this is going to be the equivalence. Now what we have that all the possible combination of the values of A and B that we can have in these statements. We can have that A is false and B is false, or we can have that A is false and B is true. Yes, so this is all the possible combination that we can have in these statements. Now let's see how this works for the conjunction. What we know is that a conjunction is going to be true only in one occasion, only when both of them A and B are true. For all the other cases, this is going to be false. So let's write that. So we have that. In this case is going to be false. In this case is going to be false as well. In this case is going to be false, and just in this case is going to be true. Now we have the negation. What is going to be the negation? The negation is just to take the value of A and negate it. Yeah. So for instance, if we have that A is true, then the negation is going to be false, and if it is false, then the negation is going to be true. So it is easy to see that this is going to be 1, this is going to be 1, this is going to be 0, and this is going to be 0. Now we have the disjunction, A or B. As you can imagine, A or B is false only in one case, when both of them are false. Yes, because in the other cases we have that at least one of them is going to be true. So since we have A or B and one of them is true, this is going to be true. So look, for A or B, when both of them is false, so this is going to be false, and for all the others this is going to be true. So true, true, and true. Now what about the implication? This one is a little tricky, but I think we can try to remember. So what we have in here, if A then B, the only case when an implication is false is when A is true and B is false. Just in this case, this implication is going to be false, and for all the other cases this is going to be true. So we have that this is true, and this one is false, and this one is true. Now the last one that we are going to discuss today is the equivalence, or if and only if. So by the way, we can denote all these logical connectors in the following way. As you can see, A and B is going to be denoted in this way, the negation in this way, and so on. But let's go back to the equivalence. An equivalence is going to be true if both of them, A and B, are true or false at the same time. In all the other cases, this is going to be false. If we have the A is false and B is true, this is going to be false. We have that the first one is going to be false, false. It means that the equivalence is going to be true. Then we have one of them true and the other false. It means it's going to be false. False and false for the second one. Now the last one, both of them are true. It means the equivalence is going to be true as well. And that's it. This is the way that we can create this truth table for these logical connectors. Now let's use this information that we already have to try to solve this exercise. So we need to show that these two statements, A implies B and negation of A or B, that these two statements are equivalent. To do that, we can construct a truth table for these statements. And we know that these two statements are going to be true in one case, when the results for all these possible combination of A and B or in this statement are the same and in this one. We are going to see that. Look, we need to create this table A, B. So for A and B, let's put 0, 1, 0, 0, 1, 1, 0, 1, 1. Now, let's put the first statement. The first statement is just the implication of A and B. A implies B. And the second one is going to be negation of A or B. Now, the first one should be easy because we already have done that just a moment before. We know that an implication is going to be false only in one case, when A is true and B is false. So look, this is false and all the others are going to be true. So this is true and this is true. Now, what about this one? What about this one? Look, we have the negation of A. I think we can make that in here. Negation of A. So this is going to be 1, this is going to be 1, this is going to be 0, and this is going to be 0. We have negation of A or B. We have negations 1 or 0. Yeah, so this is true. True or true. This is going to be also true. And the only case when the logical connector, the disjunction, is going to be false is when both of them are false. That's what we have in here. False, false. So this is false. And the last one, false and true. This is going to be true. Look, we did it. We can notice that this statement takes the same values for the different for all the possible cases of A and B. For the first one, they are true, then true, and this is just this one is false, and the other is true. So it means that these two statements are equivalent. Now let's try to solve the following exercise using the truth table as well. We have the statement F, and we want to see if this statement is a tautology. As you remember, a tautology is a statement that remains true for whatever true value that you put in the items of this statement. So that's why it is quite natural to think to use the truth table in order to find if this statement is tautology. Look, because we have all the possible combination that these true values can take in A and B. Okay, we are going to find first we are going to find the negation of B. So the negation of B is just going to be, we have that the first spot is false, so this is going to be true. Now this is true, so this is going to be false. This is false, so true and false. Now let's find A implies B, because we have in here A implies B. As we already know, A implies B is false only in one case, when A is true and B is false. So let's put that in here, that this is false, and for all the others this is going to be true. True. Now let's find this one. A implies negation of B. That's why we already find the negation of B in here, so it is easy to find this implication. So we have that true implies false. This is going to be true. We have false implies true, so this is going to be true. And here we have false implies false, so this is true. In here we have true implies true, so this is true. and the last one is going to be true implies false. So this one is the one that is going to be false. This is false. Now let's find out the negation of A. The negation of A is just going to be true, true, false, and false. Now, as you can see here, this one is for A implied negation of B, and this two is for negation of A. We are calculating this part of the statement. It does what we have in here. So we have implication. True implies true. This is true. The same in here. This is true. And this one, true implies false. This is going to be false. And the last one is false, imply false. So this is going to be true. The last one is to calculate the value of the whole statement. So look, that's what we have. It's going to be this one and this one. So we need to calculate the implication for this one and this one. We have true implies true, so this is going to be true. We have true implies true, again true. We have false implies false, so this is true. And we have true implies true, so this is also true. As you can see here, for all the possible combination of these true values, we have that the statement is always true. So this means that the statement F is a tautology.